Hey guys, so I have been stuck in this Leetcode problem. This problem was from Striver's A to Z DSS sheet, and this problem made me stuck in completing that sheet for 8 months. That means the last problem I solved was 8 months ago from that sheet. So today I'm just gonna continue the series of solving Striver's A to Z sheet and and today I will be solving this question. So yeah, I thought recording myself would be good as this problem is so iconic to me personally because from past few days I have been learning Python and I thought to give this problem another try with Python. In the past I was using C++. So let's start. So we have to delete a node simply, and we are given the node. We are not given the head of the linked list. And I went to discussion section. I thought myself initially that how could I get this node deleted and relink the whole linked list. But in the discussion section, this guy this guy discusses about the API contains only one parameter, but we don't require at least two parameters, one being the list itself, one being the node to delete or the node with the value to delete. Can anyone explain? So I don't know about why he used API and the this don't we grammar section, but I understand what he was saying. So I went to his replies and we can ignore this comment and wrote I read this that you just need to copy the next node to it. And I thought it that if I copy the next node to it, and if I keep doing this until we reach the end, ultimately we are doing the same thing. Up till now, I was thinking that linked list, if I have to delete node, I have to link the pointer to the deleted node, previous node of the deleted node to the next node of the deleted node. But this was the solution that we simply just need to copy the all the upcoming values to the current node, and the last node will simply be gone, abandoned in the memory. I don't think abundance means a lot of things. We can say the last node will be lost in the memory. So this discussion section can sometimes help, can many times help, but I have been stuck in this problem for 8 months, and not in a once I went to discussion or gave this problem much seriousness. Honestly, I each time I didn't give this problem the time it deserves. I was simply opening Leetcode and um, at most giving 10 minutes to think, but didn't cannot find the solution. So cannot thought the solution. So I just closed Leetcode and went on to other things. And now I know the key key clue to solve this problem. I will code it. So what we need to do is to copy the upcoming values in the current node. So node dot we can find the structure of how linked lists is formed, how this lead code problem uses linked lists here. So node dot val is equal to node dot. How can I access the value of next node? How can I? Node dot next dot val. Is it, is this valid for the above structure? Because I'm new to, I'm not new to Python, but currently just learning how Python goes. So I will be asking to Quinn, is it correct syntax, or is this correct syntax? And I will be pasting this, and this line is actually correct syntax. Oh, so Python is very intuitive, and we are placing the next well, and now we can. So current node value is lost. Now we will go to the next node. We need to loop, put it in the loop. We'll use while loop, while node. I think I should node node dot next is not equal to none, because the last node will be pointing to none. And while this condition is true, we will copy the current node value to the next node value, and we will update our iterating node to node equal to node dot next. Is it correct? Is it correct? I wanna know, because if node dot next, we will copy one value, again we will copy. Let me run it once. Okay, so output says 4199. Yeah, that was my confusion, that this node is pointing to none. It copied the pointer to next. No, it didn't copy node dot next. I'm stuck again in, but I now know the clue, because in the second test case also, only the last element. Up now, how do I remove this last element from the original list? That's the key, because all the middle element, uh, we can see the fifth element, we have to remove fifth element, and fifth was in the second position, and we removed five. Originally, we just copied the next node values to current node, to previous nodes, we can say. So This visually removed the 5 from the list. Now how do I remove the last node? Because node.next is equal to, okay, so value.next. I have to update node.next to none for the last element. That is, now how do I do that? Node.next is equal to none. Will it work? No, it wouldn't because the loop is ultimately getting completed. How do I have to I have to make this none. We can keep a new variable temp is equal to node. Um, am I correct? Node.next we can say. Temp is equal to node.next. It's a pointer. So while temp.next is not equal to none, node is equal to node.next and temp is equal to temp.next. And I can say make node.next is equal to name. Now elements are reduced to the size that we want, but the element we want to remove is being removed. So what's the problem? One is not being removed. Okay, I'm just playing with the values of variables. I think that way I could find a solution. So node dot value is equal to node dot next dot value. So so yeah, we are copying the next node's value. Then next node we are updating node to next node. Then node variable to next node. Mm, by mistake I opened. Can I do this? Can I? Okay, so this is doing the same as creating other temp variable, but it's not updating the last value. Okay, so node dot val is equal to node dot next dot val. Will it work? It will. Now, if anyone has test case in their discussion section, I can't find one, so I'm gonna hit submit, and this is my first submission for this problem, and the problem is solved. This problem made me stuck 8 months. I have paused solving lead code for 8 months, mainly the Stivers A to Z DSA series. And now today I solved. So I have to spend sufficient time, enough time in it. Now I understand how this problem is solved. I understand the solution. And and yeah, what we are doing is just we are checking if the next node is not none. And if it's not none, that means we are copying in simple layman's language we can say we are just copying all the elements we can understand in the test case. We are copying all the elements. If I wanna remove 5, so we are copying 1 and 9 to first and second index, and for ninth element we are stopping here at 1. And what we are doing is we are stopping here, and we are updating this one outside the loop. We are updating its value to 9, and then it's making its next to none. So the element 9 is never reached in the loop, as well as it is lost in the memory. So ultimately we can say we have deleted 5 and removed last element. That means we have made the linked list length 1 minus decreased its length, and the value 5 is being updated to the next value. That's how we deleted this element. So yeah, that's all for today. See you next time.